Okay, some more examples of sketching a Bode plot by hand. Here's the transfer function. I'll put it in this form. It makes it a little easier for me. Makes the breakpoints easy to pull out. Step one was calculating case of 0, case of naught. Let's see, in either case, you plug in 0 for us. So that'll be 2,000 over 20, which is 100 dB. That's 40 dB. Power of 2 times 20, 40 dB. The breakpoints are 2 and 10. Step 2 is the Oven table. Breakpoint at minus infinity, we have a pole at the origin, just to the power 1, so and there is -1 denominator. And the breakpoints are at 2 and 10. 2 is the smaller one, so it's the next one on the list. It's just real pole, power of 1, and is -1 there. So is the breakpoint at 10. It's real, power of 1, so that n is -1. So it's cumulatively -1, -2, -3, which makes the gain slopes -20, 40, and 60, and the phase lines at -90, 180, and 270. There's no complex terms, so we don't have to calculate the zeta. I didn't go over it in detail. You can go to my webpage and see how to set up the increments and limits of your graphs. The phase is kind of easy. The span is going to be from -90 to -270, or a span of over 180 degrees. The gain span's a little harder to figure out. I have a formula for that. Anyway, I'm not going to get into how to scale the graph so much. We'll put the 10 to the 0 here to start a second increment. Then let's see. Remember let's see, go back to the -20, -40, -60. The first asymptote, forget the whole sketch here for a second. Think of where the asymptotes are. Our first breakpoint was at 2. Doing this right? Oops. First breakpoint here is at 2. I think I was looking at the wrong chart. Here we go. First breakpoint's at 2. So this first asymptote came down at -20, right? And it has to go to this first breakpoint. So that's the first asymptote right there, -20. Then there, the slope switches to -40, goes out to the next breakpoint, which is 10. Then after 10, this slope is -60. Those are the 3 asymptotes on the gain side. Then the sketch just sort of smooths that out. On the angle side, it came in at -90. That goes to the first breakpoint, and it drops down to -180, and held constant till the next breakpoint. It drops down to -270, and then it stays at -270. Those are your straight phase asymptotes. The angled asymptotes, got a drop here, draw the midpoint. Let's see, that's at 2. 2 times 5 is 10. So here's a point, there's a point. Draw a straight line that goes through those 2 points. And here, this one, midpoint. Here's a 10 divided by 5 goes back to 2. So you could draw that dot, and draw a straight line that goes through those 2 dots. Those are your angled asymptotes. And the sketch is going to kind of go between them and end up asymptotically approaching this last asymptote. Here's the MATLAB version. Here's my hand-drawn version. Here's the MATLAB version. A little bit different scaling, but otherwise about right. Example 3, let's see. We'll add a couple of features here. We have a quadratic term or a complex term here. And we have something raised to a power other than 1. Let's see, step 1 is calculate k sub 0. Plug in 0 for s, I get 1 over 4, which is 0.25, which is about minus 12 dB. Let's see, this one breakpoint, well, this breakpoint is at 1. This breakpoint is at the square root of 4, or 2. So those are my breakpoints. Zeta, I can calculate, it's 0.5, which is big enough to where we don't have to worry about it in our sketch. So now that we've calculated it, we can forget it. So step 2 is filling in the Hoban table. Let's see, we have no poles or zeros at the origin. So the minus infinity breakpoint, the n is 0. That's a new feature of this example. We haven't seen that. So the gain slope is just going to be a flat 0, and the phase slope is going to be, not the slope, the phase itself will be 0. Then at the breakpoint of 1, well, the breakpoints are 1 and 2, so there they are in order. At 1, let's see, it's real, but it's to the power 2. And there is going to be minus 2. Breakpoint at 2, it's raised to the first power, but it's a complex term, so it's a minus 2. Minus because they're in the denominator. So the cumulatives are going to be 0, minus 2, minus 4, which makes the gain slope 0, minus 40, minus 80, and the phases 0, minus 180, minus 260. I'm going to go over how to calculate increments and the scaling of the graphs. And it's going to kind of depend on your blank Bode plots. My rules of thumb were based on these blank Bode plots. I put in the frequency increments here. But let's see. 0, minus 40, minus 8. And the breakpoints are 1 and 2. So this first asymptote is flat, slope of 0, and it was, I think, minus 12. It has to go over to, what do we say, 1 and 2. So there's our first breakpoint at omega equals 1. By the way, how do we know where it comes in or where to put this dot? It's K0. Here it was minus 12. Let's see, the previous chart, did I say that? There, our K sub 0 was 40 dB. So that's how we got this point at omega. It's always 10 to the 0 or omega equals 1. That's where we put that K sub 0. And then we draw the slope from there. In this case, K sub 0 was 40 dB. This example 3, it was minus 12 dB. And it's at 10 to the 0, meaning omega equals 1, not because that's a breakpoint, that's just where the K0 term goes. But you extend that straight line, that first asymptote, to the first breakpoint, which happens to be omega equals 1. Then the slope after that was minus 40, I believe, from the Hoban table. Out to 2, out to omega equals 2, and then after that it was minus 80. So this final asymptote has a slope of minus 80. That's the gain asymptotes, and the slope, the sketch itself just kind of smooths that out. On the phase, it starts at 0, goes to the first breakpoint, drops to minus 180, stays there till the next breakpoint, and drops down to 360, stays there forever. The angled asymptote. Take the midpoint of that first drop. Let's see, 10 divided by 2 goes back to this 2. There's a point. There's a point. Draw the straight line. There we go. Here, this guy. Draw it at the midpoint of that drop. Here's a 2 multiplied by 5. I get 10. Next, up. There's a point. There's a point. Draw a line through them. That's an angled asymptote. A sketch kind of goes between them. There's the comparison. We'll do more examples next time. We'll just keep doing a few, well, at least two more videos, one more video on Bode plots by hand.